Overheating in our homes has been recognised as being a problem, and Part O is a new section of the building regulations to address it. In the UK now, there are more deaths, over 2,000 in a year, mostly of the old and vulnerable, from excess heat than there are from cold homes. Firstly, before considering the solutions, we look at 3 problems the regulation identifies. Crucially, passive measures must be considered before air conditioning, which, as we know, has been identified by the International Energy Agency and the Climate Change Committee as potentially the greatest threat to our energy supplies. Secondly, the limitations of the passive solution of fixed overhangs, or brise-soleil, are clearly shown as only being appropriate on south elevations, and then with an unrealistic projection. Lastly, to achieve the G and TVIS values now required for glazing, it could be solved with much smaller windows, but that has other effects, not least that it is completely contrary to passive house principles. A detailed analysis of these issues can be found on our website. So, looking to the positive, passive shading with blinds and shutters is the magic solution. But is it? Before aircon, shopkeepers protected their produce with awnings, so the principle is not new. The science is simple. When short-wave light hits an object, it absorbs it, and so it converts to long-wave heat. Most of the long-wave heat will not pass through glass. So a blind in front of the glass will absorb and convert the short-wave to long-wave that is trapped, and the resulting heat between blind and glass is dissipated as hot air rises. It cannot pass through the glass. External blinds can reduce solar gain by over 90% when in the shading position, and on a hot summer's day, some can reduce the solar gain by as much as 97% when used fully closed. So which type does that? And we will specify it, but it is not as simple as that. Shading should be part of the building services and planned to coordinate with the other elements: ventilation, lighting, heating, as well as glass and structure. Also, shading is not just about heat rejection. Other considerations are occupiers' wellness and comfort, heat retention, glare, daylight, and biophilic design. But it also depends on the building type, the use, location, and orientation. So the simple answer is that there are many properties of shading, and you have to first decide what you want to achieve. In the UK, over 20% of new buildings overheat. That is mainly because many building modelling programs do not adequately consider shading, if at all. We recommend the free-to-use tool ESBO and Energy Plus that do. In the Climate Change Committee report, before COP26, overheating was one of the 8 recommendations for mitigation. Shading with blinds and shutters was identified as a key solution. It also showed that post-contract installation could be 4 times as costly, so integration in early-stage design is essential. We want to control an ever-changing climate, so dynamic automated shading is not just essential, but the cost-effective answer. As we have rightly insulated our buildings to retain heat in winter, the consequence has often been a lack of consideration or understanding of the effects in the cooling seasons. In the single-aspect apartments of our case study, in the one with external louver blinds, the temperature was 18 degrees lower than the unshaded apartment, where a temperature of 47 degrees Celsius was recorded on a day in September. Blinds are actually the insulation of the windows and the facilitator of large areas of glazing. They are not a magic solution, just basic common sense, and combined with ventilation and glazing as part of the building services, they are an essential passive measure. Above all, the priority should be the comfort and wellness of the occupants, with properly integrated shading. When we had North Sea oil, energy cost did not matter. It does now. That is now recognised, and why we now have Part O. Thank you for watching. More detail can be found on our website.